Okay, so today we are looking at special angles. In all four quadrants. All right, so Emily asked a wonderful question that got us going on the what are called quadrantial angles. So those are the angles that occur at the axes. So, i.e., 90 degrees, 180 degrees, 270 degrees, and 360 degrees, which we can also think of as 0 degrees. Those are the same place. All right? So let's start with 90 degrees, which we just looked at in that question in the homework. So at this point P, x, y, y is equal to r, because the distance from the origin to P is also the distance from the origin up the y-axis. So when we look at the sine of 90 degrees, which is y over r, since they're equal, that has to have a value of 1. Right? Since y is equal to r. So if you take a number divided by itself, of course you're going to get 1. Now, let's look at cosine. Cosine, well, what's the x value when my point is right on the y-axis? What's the x value? 0, exactly. So when we put x over r, it's 0 over r, which is 0. And that's because x has a value of 0 when it's on the y-axis. And then finally tangent, as we just saw a moment ago, which is y over x, would be whatever y is, divided by 0, which is undefined. Okay, so you can't have the tangent of 90 degrees. If you put it into your calculator, you would get some kind of error message. So, 90-degree angles make sense? All right, so let's move on then to 180 degrees. So now my point P is over here on the x-axis. So when we do the sine of 180 degrees, which is y over r, what's y value when we're on the x-axis? 0. So now we get 0 divided by r. So the value of sine of 80 is 0. And that's because y is equal to 0. Now cosine of 180 degrees is x over r. What's the relationship between x and r when our point is on the x-axis in that position? Not quite the same. X is negative, r is always positive, remember, because r is the distance. So the relationship is that r is equal to negative x. Right? They have the same value, but they're opposite sides. So what would the cosine then of 180 be?
Negative 1.
Negative 1, exactly. Okay? And then tangent, which is y over r, y over x. Well, y is still 0 here. So the tangent is also 0 at 180 degrees. Everybody with me? All right, so what I'd like you to do now is do the same thing. Give me the three primary trig ratios for 270 degrees. So when your point is down here on the negative y-axis, and also for 360 degrees when your point is over here on the positive x-axis. Okay, so fill out what the ratios are for those those two angles. Okay, so at this point at 270 degrees, our x value is 0 and our y value is some negative number, right? I'll just call it negative y. So when we're doing, and of course r, it's the same as the opposite of whatever y is, because it's the positive value. So when we're looking at sine, which is y over r, they have the same number with opposite signs, so the sign is going to be negative 1. Making sense? Okay? Because x is 0, then the cosine is 0 divided by r, which is 0. The tangent is y over x, and since x, again, is 0, and we're dividing by 0, the tangent is undefined. Okay, just like it was when we were on the positive y-axis. Now for 360 degrees, here x is equal to r, y is equal to 0. So the sign is y over r is 0 over r, which is 0. Cos is x over r, and they're equal to each other, so it's just 1. And tangent, which is y over x, is 0 over x, so it's also 0. Right? Because you can take 0 and divide it by any number. You just can't take any number and divide it by 0. So it's only undefined when x is equal to 0, because x is in the denominator of the tangent. How many people got all 6 of those correct? Questions for those that didn't? Do you understand where you messed up? Speak now, because we're just going to keep going. All right. So those are the quadrantial angles. I wouldn't expect you to memorize them. I would expect you to understand them so that you could generate them at any given time. But you do need to know them. So I could ask you on the non-calculated part of the test to give me the tangent of 270 degrees. Or I could say the sine is 1. What's theta? And you'd have to be able to work backwards. Okay? So you do need to know them. Next one we're going to look at is 45 degrees. And to get a sense of what's going on with a 45-degree triangle, I'm going to create for you a 45-degree triangle, 45-degree right triangle. So if this is 45 degrees down here, what would the other angle be? 45 degrees. So what kind of triangle do I have? Yes, it's a right triangle, but it's a little more specific than that. It's an isosceles right triangle. What makes it an isosceles triangle?
Two of the sides of the same line.
I haven't told you anything about the sides. Cameron?
They have a 90-degree angle and then two 45 degrees, or two of the same angle.
Okay, so any triangle that has two equal angles is isosceles. If it has two equal angles, does it have two equal sides?
Not necessarily.
Not necessarily. Absolutely, yes, it does. Okay? See, we don't do enough geometry anymore. No, seriously, we used to do so much geometry, and now we do no geometry, and it catches up at different points in different kinds of math. So yes, an isosceles triangle has two equal sides and two equal angles. You only need to know either that the two angles are equal, and then you know the two sides are equal, or vice versa. If I know the two sides are equal, I know the two angles across from those equal sides would also be equal. So let's, for argument's sake, say that this side length 1, which means that would be side length 1, then what would the hypotenuse be? Root 2. Be the square root of 1 squared plus 1 squared, which is root 2. All right, well, what if I made my triangle a little bit bigger? And instead of making this side length 1, I made it 2. What would the length of the hypotenuse be now? Yep. Okay, so you went 2 squared plus 2 squared, which is root 8, which reduces down to what? 2 root 2. All right, what if I made my triangle a little bit bigger? Now what's the length of my hypotenuse? Yes? Sorry? No, not 9. Be the root of 3 squared plus 3 squared, so root 18, which would be 3 root 2. Do you see any pattern? You see that the relationship between these two sides and this is always the same. How many times bigger is the hypotenuse compared to the side length of the legs? It's root 2 times bigger. So 1 times root 2. So would it matter how big I made my triangle? Would the relationship between the sides these three sides is going to be ratios for trig, they're also ratios. So the ratio, the trig ratios will always be the same, irregardless of the size of, or the length of the terminal arm. So let's put this into what we've been doing, into the coordinate plane. So if I have a 45-degree angle here, okay, if for now we're going to think of it as a triangle with those dimensions. Okay? So x is 1, y is 1, r is root 2. We can also think of it, that point we know has to be at 1, 1. So then the sine of 45 degrees, which is y over r, is 1 over root 2. The cosine of 45 degrees, which is x over r, is also going to be 1 over root 2. It has to be, because the two sides are exactly the same length. So the ratio of them, of that side to the hypotenuse, has to be the same as well. And finally, the tangent of 45 degrees, which is y over x, well, they're both the same length, so it would be 1. Now, can you see that if I had made this 2, this would have become 2 root 2, right? So if I had made that first side twice as long, then the hypotenuse would have been twice as long, and that would still reduce down to exactly the same number. So do you see how this is? Right? The ratio of this side to this side will always reduce down to 1 over root 2. So we know, if we know the angle, we know the ratios. And we don't need to know the length of any side to come up with those ratios. Okay? And if we know them in quadrant 1, then we know them in all quadrants. So not only do we know the angle of 45 degrees, if we moved into quadrant 2 and we had a reference of 45 degrees, what would our angle in standard position be? Yep. 135 degrees. All right. So we could then without knowing any lengths, come up with the sine, the cosine, and the tangent of 135 degrees. Now, are those going to change from quadrant 1?
It's gonna be negative.
Some of them are going to become negative. Which one?
Cosine and sine. I know. Cosine and tan.
Yeah. So do you see how the ratio's not going to change in quadrant 2, but the signs will, right? Because now this point here, instead of being 1, 1, is negative 1, 1. So the ratios that have x in them, namely cosine and tangent, are going to go from positive 1 over 2 and positive 1 to negative. But that's the only piece that's going to change, right? Everything else is exactly the same. So it gets a little bit sketchy to think of this as a side length, because now we have to think of it as negative 1. But you still can do that. Just remember that, of course, it's not really a length anymore. But so this will become 1 over root 2. This will become negative 1 over root 2. And this will become 1 over negative 1 for an overall value of negative 1. Remember your cast rule. It's another way. The only one that's going to be positive in quadrant 2 is sine. The other two have to be negative. Everybody with me? Okay, so what I want you to do is give me the right ratios when we are in quadrant 3 with a reference angle of 45 degrees. So tell me first of all, what's angle theta? And then the same thing when we're in quadrant 4 with a reference angle of 45 degrees. So give me those reference angles for all the three trig ratios for those angles. All right, so down here, my point is going to be at -1, -1, and my r value is 2. And over here, my point's going to be at 1, -1. And of course, my r value is 2. Or you can draw yourself the triangle. Just adjust for the fact that you're in quadrant 3 and x and y are both negative. Yes?
I thought our value
Sorry,
was
root 2. It is. Thank you. All right, so sine y over r is -1 over root 2. Cosine x over r is the same. And tangent y over x is -1 over -1. So it becomes +1 again. And in quadrant 4, y over r becomes -1 over root 2. X over r is +1 over root 2. And tangent is -1 over 1, so it's -1. So there aren't a lot of choices here. It's either 1 over root 2 or 1, positive or negative. So really all you have to do is figure out which quadrant you're in, which ones are positive, which ones are negative. So there's really only 2 to remember. 1 over root 2 and 1. Now, I mentioned to you on the first day that if it was me, I would make a little reference card that I would use as I was working through these questions. So I put on the sideboard there what I would have on it already. And now I would add to that reference card, which I'm going to allow you to use on your quiz tomorrow. This next piece. So where this is 45 degrees, this is 1, 1, and root 2. Or if you like to think of it in ratio form, a 45, 45, 90 triangle has corresponding sides of 1, 1, and root 2. So I would add that to my little reference card that I would bring into my quiz tomorrow. Okay. The last angles we're going to look at are 30 degrees and 60 degrees. And to understand the properties of this, we're going to go back to an equilateral triangle. So what are the properties of an equilateral triangle?
All the sides are the same length.
All the sides are the same length. So let's make them all 2. And what's true about the angles?
Also equal.
So, what are they? They're all 60, right? 3 equal angles, evenly split from 180 degrees, means that each angle in there is 60 degrees. Now I'm going to take this equilateral triangle and I'm going to drop an altitude. So if you remember what an altitude is, it goes from the top vertex to the base, such that it meets the base at 90 degrees. So here's where we'll see if you know what the properties of an equilateral triangle are. If I am to drop that altitude, what will that do to the measurements of my triangle? What happens to the angle at the top? It gets split in half. And even if you didn't know that, you can tell because you know the angles in a triangle add up to 180. You've got 90 and 60, so this one at the top has to be 30. What does it do to the side length? It also has to cut in half, because if you think about an equilateral triangle, it's symmetrical, right? So you could take that and you could fold it in half. That would be the same as dropping down an altitude in the middle. So this length here becomes 1. What would be the length of the altitude or the height? Not 3, but this is the hypotenuse, so it's going to be the hypotenuse squared minus the leg squared. So it's going to become root 3. Everybody agree? All right. Well, you know what I'm going to do next? Let's make it a little bit bigger. So instead of making this 2, let's make this length 4. Okay? This is 60. And we drop that altitude, cut everything in half. So what's the length of the bottom going to be? 2. What's the height going to be? People are already guessing, which is good. So 4 squared minus 2 squared, so 60 minus 4 is root 12, which simplifies down to 2 root 3. Who knew? So the relationship between the sides, it will be, again, the same irregardless of the size of the triangle. So seeing the relationship between the sides is a little bit more complicated because they're all different. So, what do we call the shorter sides of a right triangle? Legs. Okay, so we've got the hypotenuse is the side across from the right triangle, and then we've got the 2 legs. So, which leg is the shortest leg? 1 or root 3? 1. Thank you. Right? Because 1 squared is 1. And root 3 squared is 3, so root 3 has to be bigger, right? Which is the longest side? 2, the hypotenuse, right? Because 2 squared is 4. So it all should make sense. Small, medium, large. Okay? Notice that the small side is across from the small angle. And the medium size is across from the medium-sized angle, and the large side is across from the largest angle. That's no accident. That always happens in triangles. Biggest side opposite biggest angle. So that's what's going to help you remember where the sides go. Because now we're going to put this back into the coordinate plane. So we'll start, of course, with quadrant 1. If we make this a 60-degree angle, and we think about this right triangle that we can form, okay, which means the 30 degrees goes up here, what's my x value? 1, because it's across from the smallest angle. So that's 1. Y is root 3. The hypotenuse, which is always r, is 2. Remember, r is the longest length between x and y, because it's like the hypotenuse of the right triangle. So now that we have those 3 values, x, y, and r, we can find our trig ratios. So the sine is 60 degrees, the cosine is 60 degrees, and the tangent of 60 degrees. So sine is y over r, so that's root 3 over 2. Cosine is x over r, so that's 1/2, 1 over 2. And tangent is y over x, so that's root 3 over 2. So the key is to know those 3 sides and where they belong in relationship to the angles.
It's over 1, isn't it?
Yes, sorry. Just making sure you're paying attention. Thank you. All right. Now, what if we take this triangle and we rotate it around to make this 30-degree angle instead of 60-degree angle happen there? Now what's my x value? It's root 3, because the 1 goes across from the shortest angle, and the hypotenuse is always 2. So always put r in as 2 right off the bat. Then you don't. Then you only have a 50-50 chance of messing it up.
So the hypotenuse is always r in a right triangle where 1 degree is 30 degrees and the other is 60.
R is always the hypotenuse, yes.
No, I know that, but r is always 2.
Yes, R is always 2. Yeah. So now let's do our trig ratios for sine of 30, cos of 30, and tan of 30. So y over r is now 1 over 2. X over r is root 3 over 2. And y over x is 1 over root 3. Remember yesterday, it might have been last week, I told you that the sine of one angle is always equal to the cosine of the other angle of the same triangle. And you can see that that happens here again. Now, I'm not going to write down all of them in all quadrants, but let's practice finding a few in a different quadrant, because that's the tricky part. So, let's see if you can do it. Find, no. Write the primary trig ratios for, let's see here, let's do, (210 degrees) and 300 degrees. So, for sure, you're going to want to draw a diagram to start. So you can see. All right, so for 210 degrees, the first thing you need to do is draw yourself a picture so that you can figure out what the reference angle is. So 210 degrees is 30 degrees past 180. So the 30 degrees goes there, the 60 degrees goes there. Yes?
How do you know whether to, how do you draw the line? Do you, like, how do you, which line do you connect it with? Do you connect it with the x-axis or the y-axis?
Okay, all angles are measured from the x-axis. So all triangles would be drawn to the x-axis because the reference angle is here. So the triangle has to be connected to where the reference angle is.
Okay.
The reference angle is on the x-axis, so the triangle will connect back up to the x-axis. It's a good question. All right, so across from 30 is the shortest length. That's 1. Across from 60 is the medium length. That's root 3. Across from the right angle is the longest length. That's 2. Okay? Now we have to adjust for signs. So when we do sine, which is y over r, y is positive in quadrant, no it's not, so we're in quadrant 3. Y is negative, so y is negative 1 over 2 for r. Cosine, 210 degrees. Cosine is also negative in quadrant 3, so it's negative root 3 over 2. Tangent, 210 degrees, which is y over x, is negative 1 over negative root 3, so it's positive 1 over root 3, because tangent's positive in quadrant 3. Any questions about that one? The reference angle is where you start. You need to know what that reference angle is. Now, for 300 degrees, we're 60 degrees away from 360. So our reference angle is 60 degrees, which means our 30 degrees is down here at the bottom. So across from 30 is 1. Across from 60 is root 3, and the hypotenuse, or r, is always 2. So when we do the sine of 300 degrees, y over r, y is negative in quadrant 4, r is always positive. So negative root 3 over 2. Cos 300, x over r, x is positive, r is 2, so 1 over 2. Tan 300, y over x, y is negative root 3, x is positive 1, so tan is negative root 3. How many people are able to get both of those? Okay, questions? Are we getting it? Starting to make sense? Do you see how important the diagrams are? If you don't get the diagrams, you're going to be pretty stuck. So on your little reference card, you now want to add, and you can draw it either way. Those relationships. Or, again, maybe it's easier for you to think of it this way. 30, 60, 90. Across from 30 is 1. Across from 60 is root 3. Across from 90 is 2. That's the ratio in that order is how they correspond. Or write both down. Whatever will help you. So these reference cards you can use for your quiz, but by the time we get to the test, you need to know this stuff. So the reference card is to help, just hopefully through repetition, get it from that short term into the long term memory bank. That's our goal. All right, here's a different kind of question where we're going to use the same thing. So let's say I tell you that the cosine of theta is 1 over 2. Find the measure of angle theta for theta being between 0 and 360 degrees. So again, I'm going to restrict the value of theta so that you're not doing this for infinity. We only have to find the angles between 0 and 360 degrees. So when we think about our two triangles, 45, 45, 90, and 30, 60, 90. Which one has the lengths 1 and 2 in them? Yep.
No. I found which ones have cos equals 1.
Well, yeah, you're getting ahead of me. Just answer my question. Which ones have lengths 1 and 2 in them? Which set of angles am I going to be working with? Cameron?
All the 30s and 60s.
The 30, 60, 90, right? In the 30, 60, 90, we're 1 to root 3 to 2. So there are our values. So if it's cosine, remember that cosine equals x over r. So that means x has to be 1 and r has to be 2. So let's draw what that would look like. If x is 1, that means y is root 3, r is 2, so we'll move the root 3 over here. So what's that angle there in the corner? What's it got to be? Yep,
60 degrees.
has to be 60 degrees, right? Because it's across from root 3. So angle theta is 60 degrees. Now, is there anywhere else that angle, that cos theta would be 1/2? Yeah, kind of, yeah. So there's two places always that have the same ratio with the same value and the same signs. So it doesn't matter if you're looking at sine, cosine, or tangent. If I give you the ratio, there will be two angles that have that ratio, always, between 0 and 360 degrees. So the other place that cosine is positive, of course, is in quadrant 4. So the other way we could have drawn our picture where x is 1 is if y was negative root 3. So our point would be here. And now our reference angle is 60 degrees, and our angle is what? Yeah, 360 minus 60, so 300 degrees. So, you need to find both. Find one, and then figure out the other place where that would be true. Once you have the reference angle, you knew the angle was 60 degrees, just think, okay, where's cosine positive? In quadrant 1 and quadrant 4. So if my reference angle is 60 degrees, in quadrant 1, theta is 60. In quadrant 4, theta would be 300 degrees. So you just need to figure out the reference angle. All right, try this one. So find the measure of angle theta if sine theta is negative 1 over root 2. So the first thing we need to do is figure out what sort of reference triangle, if you will, has 1 and root 2. Okay? So obviously that's our 45, 45, 90 triangle, which is 1 to 1 to root 2. That's where we're going to find the 1 and the root 2. All right? So we know that our reference angle is 45 degrees. That's the first thing. Now we know that sine is negative. So we have to ask ourselves, in what quadrants is sine negative? And we would tell ourselves, yes? 3 and 4. Right? Because sine is negative where y is negative because r is always positive. Y is negative in quadrants 3 and 4. So we know that we're down in these two quadrants here. So we have one angle here that has a reference angle of 45, and we have another angle over here that has a reference angle of 45. And from there, it's easy to find out what the angles are. If you know what the reference angles are, and you know what quadrants you're in, there's not much work left. Okay? So angle theta will be 180 plus 45, so 225 degrees. And angle theta will be 360 minus 45, or 315 degrees. So, figure out what triangle you're working with, figure out what the reference angle is, then it's just a matter of figuring out what quadrants you're in and adjusting for that. Yes? Kind of making sense? There's lots going on in these questions, for sure. All right, so I want to stop and give you an opportunity to practice. Okay? We're going to do one more question off that worksheet from yesterday. I'm going to write a few questions up on the board because they're very basic ones, like this one, to get you used to it, and then we'll go back into our textbook.